Hi there children, welcome to the online revision session. I hope everybody is ready. Please spread the message to your friends also to join this revision session. It is going to be very productive for you all to prepare for the final examination due in the month of February. Now children, let us begin with this wonderful topic of trigonometric functions. As I said, I will be updating you all on what topic we are going to revise. I request you to spend at least a couple of hours a previous day on the topic which I asked you to revise, so that when we are doing the revision, remember these sums are all from outside books. Some might be from your textbook also, but the way of presenting the revision session will be highly beneficial for you all. There might be a possibility that some sums you might not complete the working because of whatever reason it is. So don't worry, at the end of the class I will share the notes with you. But only sharing the notes is not going to help you out at all. What I want you to do is understand what is happening, but the more you write, the more you are going to become better. But in case any sum is left out for copying or something like that, then I think the sharing of notes can help you to complete that sum on your own. Anyway, coming to a point, let us begin with this wonderful revision session on the first part of class 11 syllabus, that is trigonometric functions. Now, trigonometric function basically are divided into three categories, three types. The first is general proofs. The second type is based on trigonometric functions of any angles. And the third is the combination of both. That is, say this is 1 and 2 is a combination and 1 and 2. So proofs, trigonometric functions of any angles of any magnitude, that's what we are going to cover in trigonometric functions. Okay, so I'd put up some sums. From the types of the sum which I put up, you will understand what are the types of sum. Number one, how really to think on the sums based on different types, which is given in the revision session. And finally, I expect you to try as many sums as possible from your textbook exercise. Okay guys, so I think it's very clear to you all how we go about it. So let us now begin with this class or session, revision session on trigonometric functions. So let us take the first question, the first type of sum. You can see this, you have a trigonometric function and here you have to prove something. It relates to your class 10 trigonometric also, where you studied how to prove the simple trigonometric functions. So as I said, when you want to prove, either you get the LHS to RHS or the RHS to LHS, or prove the LHS and RHS simplifies to the same expression. So here let us begin with this. So let us go ahead with this LHS now. So if you see LHS, I am writing here LHS as sin x upon 1 plus cos x plus 1 plus cos x upon sin x. Now let this session be a little bit interactive, guys. You can switch on your mic whenever I ask you, or you want to answer something. So tell me now, I want to go further. Everything is in terms of sin and cos. Anybody has any suggestion what we can do over further for cutting the right side? Yeah? Perfect. So that's the first thing. Basic mathematics is going to help you in proofs. Basic mathematics, BASIC. Okay, so let us start. So now what happens now, guys? So if I find the LCM here, this is 1 plus cos x into sin x and cross multiply. So this will become sin x whole square plus 1 plus cos x whole square. I really don't know what to do, but I can do definitely one thing, that I can open this a plus b whole square bracket, and this denominator I will try to keep it as it is. So this I can write as sin square x plus, this is a plus b whole square. So a plus b whole square is a square plus b square plus 2ab. So a square plus 2ab plus b square upon, this is 1 plus cos x into sin x. Now you have to keep watching your right hand side also what you need to come to. So here there is a single term 2 cosec x, or you can say 2 upon sin x, because cosec is inverse of sin. So now you can see here this sin square x plus cos square x will become 1. 1 plus 1 is 2. So 2 plus 2 cos x upon, you can see this is 1 plus cos x into sin x. So if I take 2 common, this will become 1 plus cos x upon 1 plus cos x into sin x. So what you understand from here, I can understand 1 plus cos x gets cancelled. So eventually what is left out is 2 upon sin x, and I can write this as 2, 1 upon sin is nothing but cosec x. Please do not go on copying, it's not going to help you. We have to understand and work out with that okay, together. Let us take the next question. Again, this is the same scenario proving that, okay. This is the same scenario proving that. So sin x 1 plus tan x plus cos x 1 plus cot x. So I am directly identifying what is my LHS and trying to prove sec x plus cosec x. Now what is the best way you think? See here, you can do many things, I have no issue at all, but what is the best way you can deal with this sum? Anybody has any hint? Come on, Samrat, what do you think, what you can do here? Yeah? Quickly.
Open the brackets.
Open the bracket, okay. So what he says, this is sin x plus sin x tan x plus cos x plus cos x cot x. Okay, I really don't know how to work out with this question, because you can see this sin x plus sin x tan x cos x cot x. So it's a tough task for me how to go about it.
So what if we convert tan x and cot x in terms of sin x cos x?
Okay, see, okay, that's a very common and a good way of looking at the question. Okay, sin x plus, this is tan x is sin x upon cos x, so this will become sin square x upon cos x plus, what happens here, cos x plus, this will become cos square x upon sin x. I'm not getting what I'm trying to work out, because it's slightly tough for me. Okay, so what do you think over here we can do? Further?
So LCM?
Okay, LCM you can do, but you know there is no product here. There is plus sin sec x plus cosec x. You can do that. I will not say, but might be some steps might increase for you all. Now you know what I would think, I don't know whether I'm right or wrong, because I'm sailing in the same boat as you all are sailing in. What I will do is, if you see this sin x and this one I will pair. I will tell you why. Okay, this I will pair plus, and this with this I will pair. So that is nothing but sin square x upon cos x plus cos x. You know why I did this, I will tell you. See, when I was looking at this, I realized if I am going to find LCM of all, there is no minus sign as such that something will get cut off. So it will be still 4 terms, it will not simplify anything. But if I pair this and the third one, so if I find the LCM now separately, so this will become sin square x plus cos square x. Now sin square x plus cos square x will become 1. So somewhere I can look further to simplify. Okay, you can't learn the sum because there are thousands of questions. So every 1000 of questions I have 1000 ways of doing that. I will not say one sum, every sum is unique. So what I will do is I will find the LCM here. So what happens, children? This will become sine square x plus cos square x upon sine x plus, here I can, what is the LCM here? Cos x, sine square x plus cos square x upon cos x. Thumbs up, because sine square x plus cos square x is 1. So 1 upon sine x plus 1 upon cos x. So what do you think? 1 upon sine is what? Cosec x plus 1 upon cos is sec x, which is equal to RHS. Keep that in mind, that is very important. In the beginning, one of the child put across this point, sir, can I find the LCM here directly full? You can do that, but I have a feeling that it might work or might not work also. Okay, so keep that in mind. So that's why when you are proving something, watching your right hand side what you have to prove, you have to keep a track of what you have to prove. Otherwise, you will go and suddenly you will go out of the way. Remember this. So don't do that. Slightly, it becomes a practice, no issue. The first category of sums on trigonometric functions is nothing but proving the identities. You can't call it identities. You can call proving a certain trigonometric functions in terms of expression. I hope you got this point clear, right? So let us take the next question. Would you like to copy it down? Copy as much as possible, because I want you to write something also. Okay, 2 minutes I give you for this. Fast, hurry up. And then we will take the, whenever what is required you can understand. I will not ask you to copy, but I think this sum is really a good question. This is okay, it's not so tough. Okay, this is better one. So copy which you feel strong enough to make you feel that you cannot do this question. That sums you always try to put. But remember, the more you write, the more you are going to get. Teachers are there to guide you all, to facilitate you all. Keep that in mind. Okay, take it up. Okay, no issue. Whatever you can work out, you can work out on this. And in case anything is left out, don't worry. I'll be sharing this a part of the solution with you all in the end. But that doesn't mean don't write anything, children. Please write, don't rest. Okay, rest will always put you to test. Keep that in mind. So relax. Let us take the next question now, so that we finish what we're supposed to do. This question is a tough question. You know why? Because if you see the left hand side expression, it is given in tan and sec and all, and the right hand side is to be given in terms of sine and cos. Okay. Now the issue is over here, if you see carefully, I can convert to sine and cos, but what happens if I convert to sine and cos, I will tell you. This sine upon cos plus cos upon sine minus 1. So if I find the LCM, this will get converted to some, of course the denominator will get cancelled, but there will be a by expression here, two expressions here. By means two expressions here. But I really don't know whether that can work out. Okay, in fact I can see it, but I don't know whether you can see that. But I have a working for this question. I would put a star for this question, because this is a good question which I want to do. Now first thing, okay, now here I just remove this out so that there is no confusion as such. Okay, now if you see the LHS, I will just LHS, I will write like this first. Tan x plus sec x bracket minus 1 upon, this is tan x minus sec x plus 1. Okay, now you might have said, why you did selectively the LHS? That is the numerator to be put in bracket, right, and the denominator you are not doing anything. Let me see, okay, this is just my observation. Hint I will tell you. If you see this is tan x plus sec x. Can you see this? See, 1 upon cos is sec and sine upon cos given to both. This is nothing but sec x plus tan x. So here tan x plus x is already there. So what I will do, I will try to work out simplification here. Now if you remember, 1 plus tan square x is sec square x. So I think 1 is nothing but sec square x minus tan square x. I think it's very clear to us, right? So in place of this 1, I can put this formula. Why? Because then tan x plus sec x can be taken out common. So I don't know. Let us see whether we can work out that way. So let us write it down. It is tan x plus sec x as it is. And in place of this 1, I will write sec square x minus tan square x upon this denominator will be as it is, tan x minus sec x plus 1. As I said, why I did this, children? Because I got tan x plus sec x in the numerator, because if you see the right hand side, it is tan x plus sec x only. So if I am able to take out common tan x plus sec x, I think somewhere I am nearing to my proof. So that's the idea. So a square minus b square. Now a square minus b square is a minus b, a plus b. So let us do that simplification. This is tan x plus sec x minus, this I can write as sec x minus tan x into sec x plus tan x. I applied a square minus b square formula, that is a minus b into a plus b, upon, I really don't want to touch this because two big things I don't want to put my hand into. So this will become tan x minus sec x plus 1. Now if you look at the numerator, I can take tan x plus sec x common, right? So from the numerator, if I take sec x plus tan x common, what remains, guys? Here it will be 1 minus sec x plus tan x. That's all, upon, because I took sec x plus tan x common, so this is nothing but tan x minus sec x plus 1. Denominator as it is. So if you see carefully, I can cancel this. So what is left out now? Left part is sec x plus tan x. And what is sec x plus tan x? It is 1 plus sin x upon cos x, which is equal to RHS. Nice question, good question, a killing question, okay, but we should be having an attitude to destroy the sums as they come in front of us. Keep that in mind, okay, work. Yes?
So root sec x plus tan x to 1 upon sin x plus cos x, sin x by cos x.
No, I didn't get what you are saying. Sec x plus tan x is 1 upon cos plus sin upon cos. So that is 1 plus sin upon cos. That's what I wrote.
Sorry sir, I thought sec x was 1 upon sin x.
Okay, no problem. Mistakes do happen, okay, at your end, at my end, still it's fine, okay, but I hope you got to the point now. Next part is very important now. Next question. This is a nice question, not a difficult one, slightly tricky. Why tricky? They say if this condition is given, see koi bhi sum, any trigonometric function or anywhere, whenever anything is given to you, its relevance is there, okay. Now they are asking us to prove sin x equal to p square minus 1 upon p square plus 1. Now there are many ways to do this sum, many ways. Either you go, p is given to you, you put this p value over here and then solve it, or they had given you this, using this information you prove p square minus 1 upon p square plus 1 is equal to sin x. Okay, so one method is p value is given, take this p value and put in the RHS and see whether you get the LHS. Second method is what? Use this information and see whether I can get this expression directly. How? Let us see. So what I would try, I would do the second way of doing that. So sec x is given to you, given sec x plus tan x is equal to p, right? So if you see, there is a left hand side sin x format, so I'll convert to sin and cos. So this I can write as 1 plus sin x upon cos x is equal to p, right? Now, as I want p square, what I can do is square both the side and convert, because in the expression I need p square. So if I square both the sides, this will become 1 plus sin x whole square upon cos square x is equal to p square, right? It's nothing matlab, it is upon 1. We will see it later on. Now, okay, I got this much, I got p square plus 1. Anybody, okay, now what I can do here is, I can do something more and different. Now I'll tell you what. Can you write this as cos square x as 1 minus sin square x? I don't know whether it will work. Okay, let us see. Oh, it will come to the same thing actually. It will come to the same thing. Okay, any hint now after this? Think properly.
So 1 minus tan square x is equal to sec square x, right?
1 minus sin square x is cos square x, correct? Okay.
No, 1 minus tan square x is equal to sec square x, right?
No. 1 plus tan square is sec square.
Okay.
Okay. So what I would suggest is, because I want this minus 1 upon plus 1, that's why I am trying to work out. Ek kaam karte, isko, let us do the simplification. So this will become 1 plus sin x whole square upon cos square x, I can write as 1 minus sin square x is equal to p square. So this denominator I can write as a minus b, a plus b. So I can further go ahead, 1 plus sin x whole square. Remember, it is a square minus b square is a minus b, a plus b. So 1 minus sin x into 1 plus sin x, which is equal to p square. Denominator there is nothing, so I am putting 1. I will tell you why I am doing this, I will share with you. Now immediately what happened, because of this simplification I can cancel this. So what is left out? 1 plus sin x upon 1 minus sin x is equal to p square upon 1. Now hold on, I said never lose track of the question, okay? Now if you see the right hand side, there is p square minus 1 upon p square plus 1, right? A minus b upon a plus b. So if you see p square, anybody knows componendo dividendo formula? Do you remember componendo ratio properties you had done? A upon b is equal to c upon d. Then by componendo dividendo method, it is a plus b upon a minus b is equal to c plus d upon c minus d. Do you remember this? Children, do you remember this? These are properties of ratios which we can use in any a upon b is equal to c upon d form. Because if you see this, because I want this a minus b upon a plus b, that's the reason componendo dividendo property 10th standard you had studied this. I surely believe and understand that. So by using componendo dividendo, I can use the property here, because if you see this, I want p square minus 1 upon p square plus 1. So that's the reason. Okay, so let us see by componendo dividendo. By componendo dividendo, it is a. This is, see, understand what is componendo dividendo property. If a upon b is equal to c upon d, then by cd a plus b upon a minus b is equal to c plus d upon c minus d. So I am applying the property here. Let us see. So this is my a, this is my b, this is my c, this is my d. So by component dividendo is a plus b, a plus b upon a minus b is equal to c plus d upon c minus d. I am done with this now, just see how. So what happens now if you simplify this, sine and sine will get cancelled, 2 upon, this will become 1 and 1 will get cancelled, this will become 2 sine x is equal to p square plus 1 upon p square minus 1. So I cancel this out, 2 and 2 will get cancelled. So what is left out? 1 upon sine x is equal to p square plus 1 upon p square minus 1. But as I want reverse, ulta, so can you do the reciprocal on both the sides? So you can say by invertendo means reciprocal, that is sine x upon 1 is equal to p square minus 1 upon p square plus 1. So that's what they are asking us, that's what it is proved. Good question, tricky one. You might ask me what I started with thinking. So when a sum was put across, I thought I will use this given information and prove this expression, because it becomes easier. For example, sec x plus tan x equal to p, I could convert the sine and cos, I converted. But what happens is in the expression I need p square. So here I could generate only p. So I squared both the sides. When I squared both the sides, I got this working, and then I went with basic mathematics. I reached here. Then I saw here it is p square a minus b, a plus b. So a minus b, a plus b is this property. So I applied the property quickly here by component dividendo. I got me here, and then I just reciprocated. I got what I am supposed to prove. It's a good question. I don't say tough one, but definitely a thought pondering question. Okay, guys, so can you just take it down quickly? Good question, children. 5 marks, 6 marks, possibility. Okay, take it down quickly, fast. Hurry up. Okay, let us take it further. Okay, you can copy down later on. Now this is the second type. If you see the first type of sums what we did in trigonometric function, they were normally proof related question. The second type is nothing but values of trigonometric function is given to you and they ask you this thing. So in this case, you know, add sugar to coffee rule. Add sugar to coffee rule you have to follow, because there is specification x lies in the second quadrant. So this is the second type of sum where they tell you the angle is present in which quadrant. In the previous cases, it is presumed all these angles are in first quadrant because nothing is specified. They are all identities type of thing question, so you have to just prove it out. But here, let us read the question and try to understand what is really in store with us. Sin x is given 3 upon 5. Now this is important wording, that is conditional sums. If any question, any trigonometry, if some values are given to you, don't look at the question. Your first step will be draw the right angle triangle. This is sine theta, so this is x here. You can say opposite, hypotenuse, find the missing side. Stop. I repeat the statement. In trigonometric, any trigonometry, whenever any value is given to you, this is the easiest way to do any question coming in trigonometry. These are called as conditional sums. Why is it called conditional? Because they gave you some value of trigonometry, and at the same time, this is an important information. It lies in the second quadrant. In second quadrant, what is positive? Anybody can tell me second quadrant, what is positive? Sine and ulta. Sine and uska reverse. Sine and cosec will be positive. Sine, cosec will be positive, remaining all will be negative. Okay, great. So let us see what they are asking us. They are asking us find the, see, as I said, whenever any condition given to you, don't look at the question, just draw a triangle, find the missing sides from that particular trigonometric value which is given to you. Okay. Once you finish with this, Now they are telling find cos x, but x is in the second quadrant, so cos will be negative or positive? Cos will be negative or positive in the second quadrant? Negative. So answer is cos x, they are telling. So cos x is nothing but, if you see, cos x is adjacent, 4 upon 5, right? But as x is second quadrant, x in second quadrant, I can say for here cos x is minus 4 upon 5. Similarly, tan x also you can see, tan x will be negative. Why tan x will be negative? Because second quadrant, x lies second quadrant, only sine and cosec is positive, remaining all trigonometric ratios will be negative. So it will be tan x is nothing but opposite upon adjacent, that is 3 upon 4, but here the answer will be tan x will be minus 3 upon 4 as x is in second quadrant. Conditional sums, keep that in mind. Okay, I hope you got this point. So whenever any value is given to you, don't think right angle triangle, find the missing side, and then you see the question what they are asking you to do. Great. Now here no values are given, so no right angle triangle will come. Okay, in this case sin x equal to some value. Here there is nothing given, they are asking you simple proof, but they added a rider there that x lies in the second quadrant. So be careful. In second quadrant, only sine and cosec is positive. Okay. Now what I will do is, I will just write the LHS for you, and then we will see what I can work on. So 1 minus sine x upon 1 plus sine x plus 1 plus sine x upon 1 minus sine x. Now what you see over here, guys, I can find the LCM. So if you denominator will be 1 plus sine 1 minus, it will become square root of 1 minus sine square x, because square root of a plus b into square root of a minus b is square root of a square minus b square, and if I take this out, 1 minus sine x plus 1 plus sine x, LCM root goes, so this cancels, so 2 upon cos x. Now hold on. X is the second quadrant. So tell me, this cos will be negative or positive? Negative. Suppose you might ask me, so why are you doing in the end? You are supposed to find the value of this expression. This value you are asking, prove this. So when I found the value, I got the value this after simplifying. But as x is in second quadrant, it will become minus 2 upon cos x. Instead of writing like this, the best way is, say, 2 upon minus cos x. So I can write this as minus 2 what? Oh, something is missing there, something is going wrong. One second, let me just confirm this question because it has to be. Yes, sorry. The question itself has to be modified there because I took it by mistake, a wrong question. It is minus 2 sec x. Sec x, so which is equal to RHS. Okay, it's not a difficult one. I think this is, I hope these two varieties of question you understood. This is the second type of sums in trigonometric functions. Okay, keep that in mind. Let us take the next question. This is the third type. That is, what is the third type? T functions of angles of any magnitude. Please remember, if you want to learn 200% of the revision lectures, 100% has to be done by you all before attending this lecture. Okay? So that you understand each and every point which I share with you. Anyway, coming to the point, I want to remind you, everybody knows this, add sugar to coffee rule. Now remember, this is 90 minus theta. This is 360 plus theta, right? This is 90 plus theta. This is 180 minus theta. Second quadrant can be written like this also. This is more than 180, so 180 plus theta, and this is 270 minus theta. This is 270 plus theta, and you can write as 360 minus theta. Now this is a very important thing. Add sugar to coffee rule. This quadrant I can write 90 minus theta. Remember, this is 0 degree, this is 90, this is 180, this is 270, and when you take a one rotation, this has become 360 degree. So if you see the first quadrant, it will be 90 minus theta, or you can write fourth plus 1, 360 plus theta. The second quadrant I can write as 90, more than 90, 90 plus theta, where theta are acute angles, keep that in mind. And here I can say 180, less than 180, 180 minus theta. Third quadrant, 180 plus theta, 270 minus theta. Matlab the quadrant can be put in both this format. Both are same. Because 180 plus theta means third, and 270 minus theta means also third. Similarly here, 270 plus 360 minus. So understand this, keep that in mind. The T ratio of 180 and 360 plus minus theta, the ratio remains the same, and add sugar to coffee rule. Anyway, this is just for your quick recollection, recapitulation of whatever we did in trigonometric functions. So let us see how we go about it. Now basically this category of question, okay, this belongs to just now I told you what to do. Just now, the previous sum conditional question. So if you want me to do that. So anyway, now I'll just do this quickly for you. So as I said, a conditional sum is given to you. Don't think anything. Draw a right angle triangle. This is 12. This is 13. By Pythagoras theorem, what will be the third side? 169, 144. Is it 5? By Pythagoras theorem, find the missing side. Okay. Now look at the question. They are telling x lies in the second quadrant, and they are asking us to find the value of sec x plus tan x. Sec x plus tan x, right? X in second quadrant. Now in second quadrant, sec will be positive or negative? Tell me. In the second quadrant, x will be positive or negative? Negative. And what about tan?
Negative.
So it will be negative, this also will be negative, right or not? Because x is lying in the second quadrant, they are asking us to prove the value of this expression is minus 5. Okay, so sec will be negative. So quickly I can do that. Sec is reverse of cos. What is cos here? 5 upon 13, because this is my x here, 5 upon 13. So sec will be 13 upon 5, but I will write as minus 13 upon 5. Plus minus tan. Tan is nothing but, what is tan? Hello? 12 upon 5. So it will be minus 12 upon 5. So if I do the denominator here, this is minus 25 upon 5. Answer is minus 5. This was related conditional question, value given to you. Don't think I told you, follow this method. Just now I solved this question for you. If you see this, the previous one, right? The same pattern, this question also happens to be there. Okay, keep that in mind. Okay. Now, the third and the last category of sum in trigonometric functions. What is that? T functions of angles of any magnitude. Sine 20, sine 70, sine 180, sine 370, sine 720, sine 1025, cos, tan, any angles of any magnitude. You can find the answer for that. This is just a rehearsal for you. So I don't know cos 390, but I know what is cos 0. I know what is 30 degree, what is 60 degree, what is 45 degree, what is 90 degree. So I will try to convert this into that acute angle formula. Now what I do is cos 390, I can write as cos of 360 plus 30. So if you look, 360 plus 30 is 390, right? So instead of writing 390, you can write this in terms of 180 plus minus theta, 270 plus minus theta, 90 plus minus theta, and 360 plus minus theta. Last type of sum in trigonometric function. That is finding the trigonometric ratio of angles of any magnitude, So 360 plus theta I am done. So what I will do is, first, when I do 180 and 360 plus minus theta, what is the rule? Keep the ratio as it is. But which quadrant it becomes? 360 plus theta is first quadrant. So first quadrant cos will be positive. All are positive first quadrant. So cos 30. What is the value of cos 30? Root 3 by 2. Right? Let us take this one. Sine of, oh my god. Now here it was cos of 390, I had no issue. But here it is minus 390. So remember one thing, basic rule says, not a basic rule, sine of minus theta is a non-usable format. So sine of minus theta is minus sine theta. Similarly, cos of minus theta is cos theta only. Keep that in mind. So sine of minus theta is minus sine theta. So what I can do here is, I can write this as minus sine 390. Okay. So I can go ahead now, minus sine, I told you 390 different angle, convert into 180, 360 plus minus theta. This is nearer to 360. So 360 plus 30. First quadrant sine is positive. Positive into negative will remain negative. So it will become minus sine 30. So that is minus 1 by 2. So in short, sine of this is this value. Cos of 390 is root 3 by 2. So that's why it say trigonometric functions of angles of any magnitude. You can find the values of any angle of any trigonometric ratio. Got the point clear? Okay. Let's come to the third question. Now just now I told you cos of minus theta. Remember this is a non-usable format. So cos of minus theta is cos theta only. So I'll just ignore the negative sign. So cos of 1710. The point over here, if you see this clearly, I can write this in terms of acute angle formula, 360 plus 30, 360 plus 30 and so on. But here, I can't write 360 plus 1000, whatever the value comes up. I cannot do that. I can write n number of rotations. Remember in one thing, n number of rotations, the value remains in chain. 360, one rotation, another 360 like that. So what is my best bet for you is, divide 1710 by 360. So can you tell me, can you write in terms of rotation there? Cos of, how much is 360 into 4? So 4 4 6 are 24, 4 these are 12, 13, 14. Similarly, if I do add this 360 to it, 1800, right. I think what I can do here is, I am taking nearer to 360 and something, nearer to this angle. Can I write 5 into 360? Now 5 into 360 is 1800. Okay, 1800. Right? So I can say 1800 minus 90. Because 1800, 500, 5 6 are 30. 5 these are 15, 1800 minus 90 is 1710. Number of rotation doesn't matter. N into 360 doesn't matter. So you can write this quickly as cos of 360 minus 90. Now presuming this to be an acute angle, borderline, 360 minus theta is fourth quadrant, cos is positive. So this is nothing but cos 90. Now what is cos 90? 0. So this is my value. If you take your calculator and find cos of 1710, you will get the same answer. So from this, what I want to generalize and tell you is that any angle of any trigonometric ratio, by using the 180 plus minus theta, 360 plus minus theta, I can find the value of those trigonometric functions of angles of any magnitude. So cos of minus 1710 is 0, cos of 390 is root 3 by 2, and cos sine of minus 390 is minus half. We will see the same thing in the next sum. but in the next sum, they are given together. So, together or separate, the procedure remains the same. Okay, is that clear? Okay, let us take the next question. Okay, this is also belonging to the same previous type. Okay, I just work out. Okay, anyway, coming to point, let us see this part. Value is given upon 1. It means it's a conditional sum. So, draw a right angle triangle, guys. Don't think anything. Draw right angle. Sec is reverse of cos. Conditional sum given to you. So, I told you when some value of trigonometry is given to you, don't think anything, just draw a right angle triangle and work out. So, sec x is root 2 upon 1. It is reverse of cos. May I have attention here? It is reverse of cos. So, how you write down this? This is hypotenuse upon adjacent. So, by the way, what will happen here? This will become root 5. Am I right? No? Let me see. Might be I am doing. Suppose if I take this as A, so A square plus 1 is equal to B square. Sorry, this should be 1. I am sorry, it can't be 5. Okay, A square is 1, A is equal to root 1, answer is 1. So, oh sorry, this is 1 only because this is 1. Okay. Okay, by Pythagoras theorem, I just got the basic of it. Now, hold on. Now, what I want you to do is, look at the second thing given, because here, this is also given to you. Now, 3 pi upon 2, remember, this is 0, this 90 degree, I can write pi upon 2, 180 degree, I write pi, 270 degree, I can write as 3 pi upon 2, and this I can write as 2 pi, one complete rotation. So, 3 pi by 2. Now, if, can you tell me, x is between 3 pi by 2 and 2 pi. So, tell me this angle lies in which quadrant?
Fourth.
Third or fourth?
Fourth.
X is greater than, more than 3 pi by 2 and less than 2 pi. Greater than 3 pi by 2, less than 2 pi means this quadrant, fourth quadrant. Okay. So, fourth quadrant, you have to find the value of this expression. So, fourth quadrant tan will be negative, cosec will be negative, cot will be negative and cosec will be negative. As simple as this thing. So, let's take the values and put across now. So, 1 plus tan theta. What is tan theta value? 1. So, this is minus 1 plus cosec. Cosec is reverse of sine. So, what is reverse of sine? Reverse of sine, cosec x, root 2, reverse of sine is also negative, minus root 2 upon, what will happen? 1 plus minus 1, right? Cot x is adjacent upon opposite. Now, minus, this is cosec. Cosec is same value, but it's a negative sign here, so minus root 2. I hope I am going right here. Remember, cosec is reverse of sine. What is sine? 1 upon root 2. So, cosec is root 2 upon 1. So, I think it's okay. Now, this cancels here. So, this is usually minus root 2 upon plus root 2. Again, it will cancel. Answer is minus 1. Answer is minus 1. I hope you got this point clear. Right? Let us take the next question. Now, this is, as I said, this is a conditional sum, in this also a conditional sum, but in this there is no right angle triangle because there are no values given to you. They are just said A, B, C are angles of triangle. You given angles of triangle. And they are asking us to prove these two. These are two different questions. First one, second one. So, how to prove? Let us see. LHS equal to RHS, whatever stuff. Now, the point here I want to make is, what is given, you have to be careful. Okay, now look. A, B, C are given. A plus B plus C is 180 degree. This is given to you. Because they are angles of triangle, I can say sum of the angles of triangle is 180 degree. I have no problem. Okay. Just think over that question, 2 minutes. 1 minute I give you. Think over it. Okay, I will get the proof. ABC are the angles of the triangle. So, what is given I will write down here. Okay, I am writing it here. A plus B plus C is equal to 180 degree. Okay. Now hold on, don't think anything. Now look at this here. A plus B is there and C is there. Okay. The angle is A plus B. So I will take this C this side. A plus B 180 minus C. But I want cos of A plus B. So take cos on both the sides. So cos of A plus B is equal to cos of 180 minus C. Agree? Now cos of A plus B as it is, I am converting this into this format. Okay, I am converting this into this format. 180 minus theta. 180 minus theta is second quadrant and cos will be negative. Okay, so which is equal to minus cos C. That's it. Take it this side. This will become cos of A plus B plus cos C is equal to 0. Oh, sorry, not 180. It is 0. I took this cos this side. You know what I did now? I'll tell you. This is given to you. Great. I converted into this expression. First, I kept A plus B together because A plus B has to be together. So, I kept A plus B, took C this side. But I want cos of A plus B. So, I don't say multiply by cos. I took cos on both the sides. LHS and RHS. So, cos of A plus B is equal to cos 180 minus C. Thumbs up. Then, 180 minus theta is second quadrant. In second quadrant, cos is negative. So, cos C. Great. Take this cos C. I proved this statement. Similarly, here also the same thing. Of course, what is given to you here is A plus B plus C is equal to 180 degree. This is given. Now, let us see what I want. You can say A I want or B plus C, anything. So suppose if I say B plus C, I keep it as it is. So, can you say B plus C is equal to 180 minus A? Yes, I can do that. Now, with B plus C, I want cot. So, take cot on both the sides. Take cot on both the sides. So, what will happen? Cot of B plus C is equal to cot of 180 minus A. Agree? Sorry, I missed out one point because I don't want cot. I want upon 2 also I want. Upon 2. I want B plus C upon 2. So, can you divide both the side by 2? Yes. If I divide both the side by 2, what will happen? B plus C upon 2 is equal to 90 minus A upon 2. 180 upon 2 is 90 and A upon 2 as it is. Now, I want cot. With B plus C, there is cot. This is the proof. B plus C cot I want. So, what I can do? I can take cot on both the sides. Cot of B plus C upon 2 is cot of 90 minus A upon 2. Now, you tell me, what is cot 90 minus theta? Cot 90 minus theta is tan theta. So, I can write this cot of B plus C upon 2. Cot 90 minus theta is tan theta. Proved. Not difficult, but I really had to ponder upon my thoughts and my basic knowledge. Expression is given A plus B plus C 180 A plus. Now, what you have to prove? Get that expression by doing the adjustments as I showed you over here. So, I hope you got this point clear, children. It's a nice question, not a difficult one, just you have to understand this part. Sometimes the question can come, A, B, C, D are angles of quadrilateral. Then what you do in that case? What you do in that case? You will do A plus B plus C plus D is equal to 360 degree and then work out. I hope you got this point clear. Okay, one last set of questions now. Quickly let us finish this off. Okay, it is again something different. They are very simple question. Tan 35 is given A. They are asking you prove this. Okay, nice question. Now tan 35 is A. Now that means the value of this is given to you. They are asking you. Okay, they are asking you this. Tan 145 minus. So I told you these are not standard angles. You can convert. You can convert any angle into standard values. So that's what they are asking us to do. Now see, let us talk about tan 145. Now tan 145, I can say tan of 180 minus 35, because 145 is 180 minus 35. Now 180 minus theta is second quadrant, so this is minus tan 35. Agree? And any other angle? 125, tan 125. So tan 125, I can say tan of 90 plus 125. Something is missing there. Tan of 125.
No sir, tan 90 plus 35.
35, sorry. Thank you. This is 35. Oh. Okay, tan 90 plus 35 is 120. So 125 I wrote like this. Now again, now hold on. 180, 360 plus minus theta, the ratio remains the same. But 90 plus minus theta or 270 plus minus theta, the ratio changes. So this is nothing but second quadrant. So minus cot 35. Tan will become cot, cot will become tan, sin will become cos, cos will become sin. Only when it is 90 plus minus theta or 270 plus minus theta. Here I did not do it because it's 180 minus theta, the ratio remains the same. But only in case of 90 plus minus theta, 270 plus minus theta, the ratio changes. Now cot 35, I really don't know how to get that. But minus cot 35, I can write minus 1 upon, cot is reverse of tan, so it is minus 1 upon A, and this is A, because tan minus A, sorry. So I hope you got this point clear. So now take these two values and put in this. Tan 145 is minus A, minus tan 125 is minus 1 upon A, upon this is 1 plus tan 145 is minus A, upon this will become 1 plus 1, that is 2, right? A gets cancelled, 1 this cancelled, so 1 plus 1 answer will be 2. Now if I find the LCM here, this will become minus A square plus 1, this A will come down, will be 2A, so answer is 1 minus A square. Just rearrange it upon 2A. I am sorry. Sometimes you think too much and the complication starts. Okay, take it down quickly, fast. We have already taken up more time for you all. So I hope you got this message clear how to do this question. Okay, this can you try this question on your own? If you want, I see the working is very simple. You have to find each values. Now, for example, I'll just show you. Sine of 150, I can write sine of 180 minus 30. 150 I can write in terms of 180 plus minus theta nearby. So second quadrant it will be sine 30. Now sine 30 is 1 by 2. Similarly cos 300, it is near to 360. So I can write cos of 360 minus 60. Because 360 minus 60 is 300. So 360 minus theta is fourth quadrant. So fourth quadrant cos is positive. So cos 60 only. So cos 60 is also half. Similarly, let us take tan 225. Tan 225 I can write tan of 180 plus 45. Now 180 plus 45 is third quadrant, tan will be positive. So it is tan 45, answer is 1. Similarly, I want tan 135. I can write this as tan of 180 minus 45. Okay. So 180 minus theta is second quadrant, tan will be negative. So minus tan 45, answer is minus 1. Similarly, sin 210 is sine of 180 plus 30. So 180 plus 30 is 210. Now third quadrant, 180 plus theta is third quadrant. See, 180 is here, 180 plus theta is third quadrant. So I think third quadrant sign is negative. So minus sine 30, which is minus half. So I got all these values. Take these values and put in this. So this will be half minus 5 into cos 300 is half plus 7 into tan 225 is 1 upon tan 135. 135 is minus 1 and this is minus 1 by 2 into 3. Solve this out and you will get the answer. Homework. Okay. I hope you understood this part. Quickly I will share this working with you all. Okay. And I think next one more question is there, but this I will take it next lecture. Only this much part. But this completes the trigonometric functions in all, covering all the varieties and types. Keep that in mind. Okay. So I hope you understood. What is my suggestion is, spend at least 1 hour now after this before the next lecture starts. Next lecture I might take with compound multiple angles. Revise those compound then come for the lecture. But for this, spend 1 hour today for understanding the exercise sums. Okay. I think you will understand it more and the revision will be done properly by all. Okay. Remember there is no substitute for hard work. You need to work. Then only you will be able to cope up with better grades. So thank you very much for being with me, children. I catch you up on Friday on compound multiple angles, but request you to revise that, okay, and then get back for the revision class.